Okay, which of the following expressions is equivalent to 1 over secant alpha minus tangent alpha? So we got to basically simplify this. Okay, we want to figure out how to rewrite this. And when I think the topic says something about algebraic techniques, what they mean is that one trick we have up our sleeve to get the Pythagorean identities to work out that I have over here, kind of off screen a bit, is you can multiply by the denominator except with an opposite sign. So right now I'm going to write x because I can't do a good job with alphas. What was I saying? Yeah, so let's that's our function. I just copied it over. I'm going to multiply the top by secant x plus tangent x, and then I can't change the fraction, so I have to multiply the denominator by secant x plus tangent x because I'm rewriting something. It should be equivalent. The reason I did this is because when you multiply by two terms just with the middle sign changed, it causes the middle terms to cancel out. So if you use the multiplying through parentheses method, you'll see the bottom is going to multiply to make secant squared x minus tangent squared x. No middle term, no secant x, tangent x, because those will cancel out with one another. And then up top we have secant x minus tangent x. And you might think, man, this is just more complicated. But look, this is secant squared and tangent squared. We can use our Pythagorean identity to rewrite that somehow. Okay, I'm going to subtract tangent squared from both sides for this identity here. And that becomes 1 equals secant squared x minus, or theta if you want, minus tangent squared x. So we have a replacement to make. Secant squared x minus tangent squared x, according to our Pythagorean identities, is 1. Oh, whoops, I copied down the wrong symbol. This is a plus, right? Sorry about that. That's a plus there. This is a minus because when you multiply the two parentheses, it makes minus. So we got 1 in the bottom. So this is just secant x plus tangent x. And now we're done because that's one of our options. We said x was alpha. This one's already set up pretty nicely for us. Look, if you multiply this out, I'm going to write x instead of beta, okay? You get secant squared x minus 1, because you get secant squared beta plus secant beta minus secant beta. Those cancel out, and then times a negative 1 at the end. And if we divide that by secant squared, write an x. This sounds like a trig identity. I'm just going to subtract 1 from both sides here to get tangent squared theta equals secant squared theta minus 1. So the top is tangent. And the bottom is still secant, so we haven't simplified anything. Well, we haven't made anything cancel out yet. But you can rewrite this as tangent squared x divided by secant squared x. And then we can put everything in terms of sine and cosine. Sine squared x over cosine squared x. And then I'm going to flip and multiply. This is 1 over cosine, right? So when you flip and multiply, that's cosine squared over 1. So these cancel. Leaves you with sine squared x. So they're little puzzles to unlock, right? They're fun for me. I don't know if they're fun for anybody else. I like them.